Okay, so this lesson is going to be on combining like terms and the distributive property. We're going to start with combining like terms. So remember from class that a like term has to have the same variable raised to the same exponent. Or in this case, it might have no variable at all. So if we look at the first one, what I like to do is underline anything that has one variable. I underline it once. So here 5n has a variable and 10n has a variable. When you're underlining, be sure to make sure that your underline covers the sign in front too, so you can keep track of the signs. So those are like terms. So I've got 5n plus 10n. Then ununderlined, I've got here this -2 and this +2. So those are like terms with each other. So now I can go ahead and I can add my like terms or combine them. So 5n and 10n, that's 15n. And -2 and a +2, those guys cancel out. So 15n is the answer for this problem. Let's take a look at the other one. Remember that when the variables are the same, they also have to be raised to the same exponent. So x squared is a like term with x squared, and x is a like term with x. So here, I like to underline the squareds twice. So I go through and I underline all of the squareds twice. And then the x's, with just the variable, I only underline those guys once. And I can keep track. So here I've got 3x squared plus 2x squared plus 2x squared minus 4x minus 6x. So I'm going to do a little scratch work here. So I've got my negatives and my positives, and I just want to keep track of them. So the 3 is on the negative side, and the 2's are both on the positive side for these x squared terms. So that's 4 positives, 3 negatives, which leaves me with a positive x squared. So I could write that as 1x squared. Then I'll do a little scratch work here for these x's, and I've got a -4 and a -6, and so that combines to give me -10x. And now the x squared cannot combine with the x, so this is my answer. You may also choose to write it, if you would like, as just x squared minus 10x. These mean the same thing, so they're both acceptable.